Bhunesh and Anurag. This discussion is mainly about Terraform. The core concentration is on Terraform. And we want to use a use case so that we understand things better, how Terraform really works. So two aspects we have in this session. One is uh, understanding Terraform better, and also one real-time use case implementing through Terraform. I don't have any PPTs. I'm not big fan of PPTs. So I will give the explanation. Let me illustrate what we are going to achieve, and slowly let us set up a workspace, Terraform workspace, our project workspace, and we implement that, and let's close it. And feel free to ask questions in between if you have any doubts. All that. Let's make it very interactive and see if we can benefit from this. Okay, so the use case we want to implement using Terraform is it's on Amazon Web Services. The use case is this. Right. We have a queue, and we receive messages into the queue. Let's say there are two different applications. Application one wanted to send some information to application two asynchronously. Queue is the option for integrating applications asynchronously, correct? If it is synchronous integration, we can make API calls. So if applications do integrations with API calls, both applications should be up and running. When it comes to asynchronous, right, the advantage would be even application two is down, right? No issues, like application one can still push its data into this queue. Application two, maybe it's down for a few minutes for maintenance or whatever reasons, it will still have messages here. And once application comes online, so it can pick and it can process. Correct. Now, so SQS, simple queue service, that's the main component receiving messages. And we want some transformation between queue and S3. So we want to pick up the message, we want to transform it, and we want to place it in S3 bucket. Let's say later, there is some other application which picks data from S3 and will ingest into Redshift, and it's used by data team, etc., etc. Okay, but we're not focusing on all that aspects. Our main focus is on this piece, like queue, SQS, and Lambda functions. I wanna use Lambda function for this use case. Yeah, there are different ways it can be implemented. We can have a small batch job which will poll this queue every 5 minutes, 10 minutes, look for messages. If present, take it, process it, push it onto S3 buckets. That's possible. Just a second. Yeah, sorry guys. Uh, let's have Lambda function, and let's configure Lambda function as a event. Means when messages come into queue, it calls Lambda function. We will write this function in Python, and it does some transformation logic and uploads that file onto S3 bucket. So this is what we want to build using Terraform. And yeah, Anurag, you have any knowledge on Terraform? You said you guys usually make changes to Terraform code, right?
Yes. I had knowledge of it.
Knowledge, right? And
Yeah.
Bhunesh, what about you? We can't hear. Maybe you can send a text.
I think he's not active, Hari. I think we can continue this session and we will upload this. You can upload this on YouTube
That's
such that
okay.
most of the viewers can be utilize it after some time.
Yeah,
Because there are a lot of subscribers for your channel, right?
that's
So
true.
if anyone get doubts, right, they will be utilizing this video. Not currently. In future, it will be much more utilized.
Yeah, he replied, Bhunesh replied, I'm active. I have microphone issues. No worries. No worries. Yeah, let's go ahead. So fine. So this is what we want to build using Terraform. So what I do is, let's prepare our workspace. Let me open my terminal. Let me go to for my reference. I'm creating this LinkedIn IEC. Okay. CD into that. I'm using Visual Studio Code, which is a very popular editor for multiple languages, multiple tools like Python, Java, uh, Terraform, yeah, CloudFormation templates. It's very nice too. So let's use Visual Studio Code and let's create a workspace. Why? Because we want to start everything from scratch. Then I want to make sure we configure AWS access. I will simply give steps. Okay, like see, uh, step one is these things you guys can do yourself. So create IAM user with full access and get access keys, secret keys. That's first thing you have to do. And second, install AWS CLI on your laptop. That's second thing. And third, run this command, AWS configure command. So it lasts for access key ID, secret, access key, region, and output format. So provide access key. You get this in step one. And provide a secret access key, specify region, in which region you want to create resources, and you can leave output format blank. It uses a default output format. So once this is done, on your local AWS keys are configured, and same keys will be used by our Terraform. Okay, so let me close this because we don't need it. So here, I want to first set up a few initial configurations for Terraform project. Uh, Let me create provider.tf. This file name can be anything. Extension matters. .tf, that matters. File name can be anything, but it's good always to follow conventions. Terraform supports multiple providers. It supports Amazon, Azure, Google Cloud, DigitalOcean. It supports about 20 plus providers. So that's why we need to pinpoint which provider we are using. So do that by defining provider block, specify name of the provider, and optionally configure region, access key, secret key. You can configure access key, secret key, all that stuff here, but not good idea to keep tokens in the code. So I will put only region. I want this in US East 1, and access keys, secret keys, it picks from my local, which was configured through AWS CLI. It's already done on my machine. So I gave only steps and it's already done on my machine. My machine is pre-configured with access keys and secret keys. Okay. Now let's do init. Terraform init. We run init occasionally, not always. We run it when we set up the project. This will install provider plugins. We are using AWS Cloud Provider. This will go to internet and it will initialize current folder with provider plugins. If you want, you can mention specific versions. Let's say you want to say, I want to use only specific version. That configuration is also supported by Terraform. Okay, the initialization is done. And let's go back to our diagram and we want to build this one. So what I want to do is, first, I want to set up my queue through Terraform. Okay, I can go and write this code in provider, or I can create sqs.tf, write code there. That's okay, but we have better way to do this. I want to implement this in a modular format. I want to use Terraform modules for this implementation. The advantage of Terraform modules is reusable. So today we are setting up one queue. In future, we may have to set up second one, third one. And if I use modules, it is one-time stuff. So once you write the module, you call it. You simply call it. Today, we want one queue, we call it create queue. And let's say down the line after 6 months, we want second queue, right? Simply call it. You don't have to write again. So that's the power of modules in Terraform. So I will show you the best way and best folder structure to maintain when working with Terraform projects, that too when we follow modules. So create a folder. Let's name this modules. Folder names can be anything. There is no constraint on names, folder names. It can be anything. So, but I would like to go with modules. And inside modules, I want to first create Sqs, right? Q. Then I want to create Lambda module. Then I want to create S3 bucket module. So under modules, create a subfolder, Sqs. Likewise, create S3, create Lambda. But first, let's finish Q. Let's write Q, then we can think about writing the second module. So under Q, create a file, main.tf. To repeat, names can be anything, but we are following best practices. So main.tf, which contains the main resource block for creating queue. So what I do is go to internet, Sqs, search for Sqs and go to its page. Take this, paste it. Paste it. Resource type. This tells Terraform we are interested in queue, Sqs, right? This is logical name. Logical names can be anything again. Name of the queue and other attributes of the queue. Like if you want to configure What is that? Dead letter queue means when a message is processed, it's failing. You want to push it to a dead letter queue so that we can later fetch those messages and inspect why it is failing. Got it? So for our demonstration, we don't need these things. I want to go with very simple, basic queue. So here we can parameterize these things so that it is reusable. So what I want is, I want to have variables .tf. Say I want to make this reusable. To make this reusable, I should not hard code like this. Got it? So I will define them as a variables. I will just define one or two. The rest you guys can take care. So variable, I will say, I will put name and delay seconds. The rest you can take care. So variable, that's the syntax. Variable is the keyword. Name of the variable. Queue name. String. And if you want, you can give default value. Otherwise, don't specify default value, your choice. Variable, delay seconds. So for this, what type of data? It is number, right? Number. And type is number. Default, let me keep 0. So we are going with two variables. So here, use variables, var.queueName and var.delay seconds. So you can make other arguments also variable so that caller can change them on their need. So we have variables, we have queue, right? And let me execute this and create a queue. For execution, we need to maintain a project level main.tf, a project level variables.tf. This is a module level main.tf and variables.tf. So if I execute Terraform init, if I execute Terraform apply means take everything from current folder and execute the code and create resources. Let's try this. It says no changes, but we expected it creates queue. Why? Because what's happening is it's only considering files in current folder. It will never look for subfolders. So it is only picking this. It says only provider. There is no resource blocks here, so it's not caring about it. But I want to create queue, but it is in a subfolder. I said Terraform will never go to subfolder by default unless we do something. So that is this. Let's separate this. Let's provider be separate, and let's have main.tf for the main application. Main.tf. So in main.tf, I want to call queue.
Hari, I had one doubt.
Yeah.
So can't we run the Terraform init or Terraform apply or plan in subfolder? Like we can navigate from the command line, right? CD modules. There we can go and we can run and test, right? Whether that module is working properly or not.
But what happens? That becomes a separate project. If you run Terraform init inside Sqs, it becomes a separate project. And if you run the same under Lambda module, it becomes one more separate project. But I want everything into my main project.
Okay.
Okay. And yeah, I want everything into my main project. Otherwise, every module will be like its own project. Let's say tomorrow you have 100 modules and you want to deploy this from Jenkins or like that. You have to go into every module and do this. but I want to say Terraform apply once, which takes care of everything.
And one more doubt, Harim. Uh, so if we want to find out the errors, right? So whenever we write a module, so we will be having some doubt whether it will be any working fine or not. It may contain errors or not. We need to cross check, right? So if we run from the main, right, it will be any much harder because it may give you any errors which are present in the modules and which are present out on the root folder also, right?
Right.
So is it not a easiest way that we can check out our module is correct or not by running the Terraform commands inside the module?
We can see, one is syntactically we can check. Syntactically we can check, like there are commands to run a syntax check on a module, and you can see, is it syntactically correct?
So you mean syntactically correct means Terraform format and Terraform validate, right? That is what you mean.
Yeah, validate.
But yeah, that you can do. That also we can. That is also you need to run on subfolder, or you are going to run it on main folder.
Yeah, see, if that's what, if you orchestrate everything from your main project like this,
yeah,
okay, you can run directly on the main. You don't have to run it on subfolders. But if you want to run it only on a module, you can navigate there and run Terraform validate. That's also fine.
Okay.
But the point is, see, complete. We want to create complete stack in one apply command. So that's why we have project level main.
Okay.
And see this, I'll show. I'm calling a module. This is the syntax to call a module. So module, name of your choice, source is current folder / modules / SQS, right? And this module takes two variables. Delay seconds, even if you don't pass, it takes 0, but queue name is must, correct? Queue name, let's call this, right? Now do apply. Module not installed, run Terraform init. I told you, right? You don't have to run init every time. You have to run init first time for initializing your project, and next time onwards when you refer to new modules. Do apply, or you can do a plan. If you want to know what it's going to do without doing, plan is also one option.
Hari, I had one more doubt.
Yeah.
So when you are writing Terraform module, right? The minimum thing is like a source. We need to define source. Rest of things are optional. We can pass out variables or may not pass the variables. So I can see here you passed only name variable, value to the name variable. So other values you didn't pass it, right? For example, there is something like a delay or something that is you mentioned it as a 0. So if we are not passing it, is it going to take the default value which is present in the module folder?
Yes.
Even though if we are not calling it?
Yes, you're right.
Yeah.
This goes with 0. But here we don't have default value. We must pass.
Okay.
Here, if you don't pass, 0 is default. And if you want to override, you can override.
Okay.
Let's say delay seconds, you want to make 30, you can override. Got it?
Yeah, thanks.
And if you see plans, plan is one more way you can check, is it going to work? Are there syntactical issues? A plan is also a way to check. Plan will tell what changes it will make if you apply. It says it's going to create queue with these details. It says overall one resource to add. Let's apply. Now It is reading main.tf. It's reading provider.tf. In main.tf, we declared a module. We're calling a module. So now it executes this code and creates queue by using these inputs. Anurag, you're fine.
Yeah, Harish. Yeah, understood.
Yeah. It's waiting for a confirmation. Type yes. So that's going to create queue. SQS. Java home queue. Correct? And we're good. In future, if you want second queue, give like this, and we are done. Maybe for second queue, you want 300 seconds for delay seconds, and you want to give some other name. It creates second queue. That's the power of module. Right. So we are good with module, SQS module. And the next module I want to create is Lambda module. So click on modules, right click, new folder, Lambda. And inside Lambda, create main.tf. And let's create variables.tf. Main.tf, variables.tf. Let's figure out Terraform resource for Lambda. Lambda, AWS underscore Lambda underscore function. Yeah, it needs a role. We'll create. See, here we want to set up Lambda function, and Lambda function will call receive message on queue. For that, it needs IAM role. Okay, so this needs IAM role. So we need to create a role. That role allows Lambda function to say receive message. That is required. And it also needs permissions to upload files to S3 bucket. Okay, so let's go and create IAM role. Then in the same module, we will create Lambda function. Once it is done, then we will see creation of S3 buckets. Okay. Let's use this one. Here, it creates a role and assume role policy. Assume role policy in AWS assume role policy is nothing but who is going to assume this role. It is a service, Lambda service. So service Lambda Amazon AWS.com. If we are creating this role for EC2, it will be EC2. Okay, right. So that's cool. Assume role policy, and we need the policy itself. Policy should allow Lambda to make calls to SQS and also to make calls to S3. we want to create the policy document. See, there are many resources for IAM role. So I will go with this one. Okay, I'll go with this one. AWS IAM role policy. In Amazon, role policies are JSON documents. It has a version, it has a statement. See here, action, SQS, fine, and a specific operation. So on SQS, I said receive message permissions are required. Let's go to policy generator. Open that. This is IAM policy, SQS, yeah. You'll find receive message, okay. And Amazon resource name, ARN. The ARN of the queue, this one. Okay, and you can have conditions if you want to. So it should look like this. SQS receive message. Effect allow, and resource on this. So this is statement one. And similarly, we need one more statement, that is on S3. S3, like we want put object. So we will we will replace this later. Okay, we will replace this later. That is second one. So number one, number two, and we need one more for this one, CloudWatch logs, because Lambda function, when it executes, we need logs for troubleshooting. So we need to provide permissions for Lambda function to push messages to CloudWatch. So I repeat, first action is for queue, second action is for S3, and third action is for CloudWatch logs. I will get it from my previous role. Go to roles. No. One second. Or highlight, one second. Okay. So I'm navigating this just to pick this one. Yeah, so I want this. One more statement is this. Copy. missed it. Be careful when you guys do. Yeah. Remove this. So in actions, right? When it comes to resource, for the sake of simplicity, I'll keep star. Okay, now I will format this CD modules and format so that it organizes well. So this creates a policy. Let's rename this. Role ID. This is role ID. Correct. So now this policy gets attached to this role. This is fine. Now the next step is.
Hari, I had one doubt.
Yeah.
So there in resource field, you are mentioning as in a star, right? Actually, what should be the actual input over there?
See, ideally, it should be the actual log stream. Means this is for storing logs. Okay, I'll tell you. Go to CloudWatch. And log groups. Unfortunately, I don't see that. Okay, it will be like this. It will be like this.
Oh, okay.
Okay, it will be like this. And in that case, right? In that case, this one should be the name of Lambda function. So how it works is when you create Lambda function with create log stream, put log events permission, it's going to create with this name here. See this? When we run, it will be like /AWS/Lambda/ the Lambda function name we choose. Yeah. So I'm keeping it star, not good idea, but we should always give a specific resource, specific permissions. This is good, but this is not okay in production. Okay, so let's do
one more thing for SQS. You mentioned 2 times. Resource, you mentioned it 2 times. One is for SQS and another is for Amazon S3, right? You mentioned 2 times SQS.
What is it? Maybe S3 I mentioned 2 times, looks like. Yeah.
Yeah.
We need to change this also. Because this must be ARN of the bucket. It should not be the queue. So we'll keep it like this for now. And later we'll see, let's keep it star for now. Later we'll change. Okay.
Okay.
Yeah. Now, so I'm in the main folder and let's call the second module. Lambda and Lambda. We're not having any arguments right now. It's taking all default. Apply. Okay, you know, right? It's new module we are referring. Run init. Cool. Now apply. So we can use auto approve so that it will not prompt us for our, approval. Okay, fine. So you got it right. It created IAM role, and let me check the name. Yeah, IAM for Lambda. You can click roles to refresh. IAM, see that IAM for Lambda. Trust relationships, it's Lambda, and permissions, it should be the policy. Queue, bucket, and so on. And after policy is ready, we need to create this function, this one. So let's take this. And I will do one thing. I will make this role.tf. Okay. Where is the tree name? Let's make it IAM role.tf, and let's create fresh one with main.tf. In main, let's put our Lambda code. It takes some more time. Is it okay? Okay. So a few things I want to make as variables. Runtime. I want to make runtime as a variable. Variable runtime type equals string, and default Python 3.9. Okay, this is default. So take this. So likewise, environment variables not required now. See, likewise, handler, you can make it as a variable. Function name, you can make it as a variable. Let's make function name as a variable. Function name equals to string default. Okay. Default. Yes, my function. So here, oh, function name. Okay, leave it. I'll tell you. I will tell you. Okay, we can make it where dot function name. File name or function name? Yeah, this is function name. I'm sorry. Where dot function name. So likewise, right? You can make them variables so that caller can give any input and create function. Yeah, just a minute. Okay, cool. So, and we want to use Python script for this, correct? I want to use Python script. I will keep that script here, or we can have the script in a separate location. So let's do this. Let me keep it in a separate location. Let's create a file, separate folder, sorry, Python. So inside Python, let me create one more for, let's call it process Sqs. Inside that, process dot py. Okay. So let's keep this empty for now. First, let's create a function, and we will see logic later. Right. So coming back to Lambda main, I need to create a zip. Okay. To create Lambda functions in Amazon Web Services, one option is create a zip, upload it. I'll show you how to create zip here. There is data archive file. This one, right? It's of type data. It is not of type resource. This is of type data and archive file. This creates a zip. This creates a zip. Zip, right? It takes few details. Let's get it from its document. Terraform data archive file. Yeah, this is type zip source file output path. Okay, so if we are using modules, we need to take help of this module path. Otherwise, it may fail. So we are in Lambda folder now. Okay, from Lambda folder, go one directory back, which becomes modules. From modules, go one more directory back, which becomes root. From root, go and find it in Python folder. So here, one directory back, one more directory back, Python, under Python, process -sqs. Process -sqs. So under this folder, process_sqs.py. Process_sqs.py. Remove this and put same here, but keep the extension zip. This takes care of picking this file from our specified location. It picks this file, creates a zip, and that zip we want to pass here. To pass that, data dot archive file dot lambda zip dot output path. That's it. That's it. So it's going to pick this zip and create a function. So function name, role we have within our code, correct? In the same, in a different file, IAM role. Yeah. So role handler, this is important. So for this to work, I need to fill some data in this code. Yeah. See, in AWS, Lambda functions has a specific format. It takes two arguments. One is event, other one is context. Let me keep it blank, okay? Just I need a just bare method without any code. Let's have this. So coming to this one, handler, it should be the file name. File name is process_sqs dot. See, the file name is process_sqs and the function name. You can name this function with your choice. You can make it ABC, XYZ, whatever. So whatever name you provide, and that name should reflect here. Okay. And it's going to calculate this source code hash, so that only if there is a change, it will deploy. Otherwise, it will not deploy. Just a minute. Sorry, man. Yeah, see this one, what this guy do is, it will calculate the SHA. Means if the file is changed, SHA will change. If SHA is changed, it will redeploy the function. That's why we should have this. So here also, it must be our zip file location. And this looks perfectly fine for me. This looks perfectly fine for me. And one more thing, instead of empty, let me say print event. Let's deploy this and see the output. Later, we'll continue on that. So shall I apply? Inconsistent dependency log file. Okay. Why, sir? Lambda, are we? Yeah, let's use function name. Process Sqs S3. Just inconsistent. Okay, let me do this one. Upgrade. Let's say pro. Cool. That created Lambda function. Let's check. The functions. Process Sqs S3, LinkedIn, and the code, which is dummy code. That's cool. The next step is I want to map. Okay, I want to link my queue with Lambda trigger. Means when message is posted, it should call Lambda, and Lambda will take it from the event and process it. So that link I need to create. The form Sqs Lambda trigger. This is for Dynamo, Kinesis. Okay, Q. Take this. Go to Q because we are doing it in the Q side. Go to Q. Event source ARN function name. Event source ARN is this. Right. And function name, where is that function name? Function name is in Lambda. So make this variable. Var dot Lambda function name. So take it, declare in variables. Leave it blank. So if you're calling queue, you must pass this, otherwise it fails. Let me run this, it will fail. See that Lambda function name is required. Lambda function, go to main. So here, right? Here. Yeah. I will pass same name here. That's it. I think you got what I'm doing. Now it will create the link between Sqs and Lambda function. Go to queue. Which queue is that? Are we using correct values? Queue. Is it asking function name or anything else? Let me cross check. Oh, it should be function ARN. I'm sorry. It's not name. It should be function ARN. That may be a reason it's hanging on. Function ARN. Okay. Now, let me return function ARN from this module. From Lambda module, create a file, outputs.tf. Modules can take inputs and it can return outputs. So this is one scenario where outputs are required. So I want Lambda ARN so that I'm making changes to Lambda outputs file so that it returns ARN, which I want to use it in Q module. Value equals ARN. So return that. And in the main, we are passing it here, right? In the main, module.lambda.yarn. This will work. See that this is returning, and that return value I am passing to my queue. Stop this. Okay, are you guys getting late?
No hurry, you can continue, please.
No issues, right? Yeah.
Sorry, Hari, I had a confusion related to output block, right?
Okay.
So how to repair output block, that is, can you please explain?
See, simple. See, let's focus on this main .tf file. We want Lambda ARN, correct? Here we want Lambda ARN for that event configuration. But Lambda is separate module. Lambda ARN is present in Lambda module. If you go to Lambda, we are creating Lambda here. ARN will be present in the same module. So because in my case, I want this ARN, so I will return it. I will define return type of my module. So I can access like this, module dot lambda dot whatever is returned by this Lambda module. So if you see outputs, output any name, this is a variable name. Your choice, whatever name you want, you can. And value is important. See this, the value. Lambda function, logical name, .arn. So this is returning ARN, and that we are referring in Sqs module. Anurag?
Yeah, Hari, understood. So here the thing is module block, which contains an output block will return some value to the module which it is called in the main block,
Correct.
main module, nothing but a calling module.
Correct.
And that calling module can pass the values to the another module. That is what the here concept, right?
Correct. We're using values of one module in another module.
Yes.
We are doing that using outputs.
Yeah. With the help of output, it is getting the values from the child modules.
Yeah.
Yes.
Why it is still going on? Let me cross check again. Yeah, function name ERN. Okay. And how your modules or how your code looks like, Anurag? Means going on.
Yeah. See, my code is very, very small. I did a very less amount of work on Terraform, actually. It is very simple module, not with Lambda. When I see this Lambda, it's too confusing for me, and I feel it's difficult.
See, first thing, right? You should know what is Lambda. So here in this demo mainly, if you know what is Lambda, what is Q, what is S3 bucket, and you can focus on Terraform. But if you are from Google background, GCP background, so obviously you have to focus on Terraform as well as you have to focus on what is Lambda. Not sure why it's taking this much time. Generally, it should come here like this and save. It's a very simple operation, but why it's hanging on, I'm not sure. Okay, so let it move on. Now we are almost done with this and this. So what I do is let this go on. Let's quickly set up S3 module. See, I'm using very basic one, okay, and not very advanced. So under modules folder S3 and new file main.tf. Okay, I'll keep it very, very simple. Modules, right? We can keep on improving them. I told you I will keep it very simple. That's it. And let's take this as a variable. And okay. Yeah, that's it. Very simple. I told you. Bucket name. Okay, in the main module S3 source modules S3 bucket name. Okay, bucket name. Invalid parameter value exception. The pro. Okay, the provided execution role does not have permissions to call delete message on SQS. Is it this one? Okay, it's taking time. Let's see if it comes with an exception again. Looks like not yet. So let me try manually and see if it throws any other exception. It's working good, right? I'll delete why because manually done. Okay. It's our policy got updated, but it's not take this much time usually. It's taking so much time. Meanwhile, any questions we can discuss, Anurag and Bhuneshwar?
Nothing, Hari. Hari, do you teach Python also?
No, only in terms of AWS. Anurag.
Okay. In
Mhm.
terms of AWS means while in the AWS classes, you will teach some basic
Correct.
Python.
Yeah.
Mhm.
Hmm. Oh, it's going to fail again. I don't see any. Okay. Or what we can do is instead of waiting, right, temporarily, I will comment this code. This one in the queue. I will comment this. Okay. And I will, for time being, because we don't have time, for time being, I will configure this trigger manually. Okay, let's do it manually. And get attributes. Okay, now see it's giving a different issue. Okay, so one fix is quick fix. Okay, one quick fix is not good idea, but this will help us. Okay, no problems. Last try. Let me delete and give a last try. It worked. Oh, I'm sorry. Hmm. Yeah, done. It's working now. Good. The next step is, right, I want to test this one. See, when I send a message, say, demo message, let's keep it 0 so that it will immediately publish. Because we have this trigger, right? We have this trigger. It calls this function. And if you check, if you click on monitor and if you click on view logs, you'll find logs for that. Okay. Is it correct? No, this is different one. I don't see. Okay, I will test it here. No worries. It's working fine, right? It's working fine. Then why process SQS and then not watching? Yeah. No, why is not configuration? Let's see if it has permissions. Okay, log group creation permission not there. Okay, so I will also make it star. Also make it star and apply. Why it was not showing in CloudWatch logs is because it doesn't have it didn't have permissions to create log group. That was the issue. So let's test from here now. So send. Do a send and it goes to Lambda and we should see the fourth one. Okay. Maybe this 30 seconds delay will take some time. Let me remove and send again. I'm sending 2, 3, or 4. Okay, and code. Let me test again. Test again. Test again. Oh my God. This is strange, really. It should change. Should change. Logs. I gave all. It's updated. Yeah, it's updated. Logs. That's cool, actually. Not still getting why. Okay. North Virginia. This is North Virginia, I guess. And Q is also North Virginia. It's a bit surprising. It's not even throwing exception, and is it because of I see that now. Yeah, this is fine. Let me delete and let me test from the queue. 0 seconds. Now I see that. Yeah, it's coming. You can see this one. A lot of metadata is present. So in that metadata, you can find this body message. This is test message. Copy. If you have time, I can finish it in maybe 20 minutes. See, this is the body we're getting. And in that, the message is part of body. So here in the code, message equals event of records. See that navigation records, it's array records of 0 under this one body, yeah, body, and print this. And for testing purpose, I will delete this log stream and go back and just do 0. Second, third, okay, third, and here to refresh. Yeah, this is test Sqs message, test Sqs message 2, and we sent 3. Test Sqs message 3. Now, anytime a message is published, it's coming here, correct? And the next simple one, we are closing it, almost we're done. The simple one is take this message, create a file, send it to S3. Open. I'm opening this file in a write mode. Write the message and close. See, open a file, write the message coming from queue into that file and close it. After you close, send this file to S3 bucket. Boto3 S3. Boto3 is Python SDK. So either we can use upload file. Take this. I'll have it here. Okay, see this one, S3, upload file, file path, bucket name, where is that bucket? There's that one. I'm hard coding, but we can make it dynamic. Bucket name and Sqs dot JSON. Deploy. Deploy. Go there. Let's make it message 4. Send. Message. Yeah, that's it. Send. Open S3 and check for the file. See this sqs.json. You can download and you can open and it says that. Okay, if I send again, like a second, third, fourth, okay. What happens is, see, it will have only one file. Why one file? We hard-coded file name. So file name is hard-coded. It's always same. But if I do that, what happens? All previous messages will get overwritten. Only the last message will be present. So I want to fix this. To fix this, I will use message ID. See this? I will use message ID and I will use this as a file name. Take this, come here. I'll call this file name equals event records 0 message ID. Got it? Records of 0 from that message ID. Cool. Now, file name here, right? Here. In Python, what I do, I will use a format stuff, file name dot JSON. So deploy this and test this. Message 4, let's say message 5, message 6, and go to the bucket and see these ones. Like every time a new message comes, ID will be different, id.json. And now to finish this off, what I will do is take this code, Is that one? Yeah, here. That's it. So because we want to deploy from local. That's all. So I will share this code with you guys, Anurag, Bhuneshwar. You can share your mail IDs with me. If you're okay, you can share your phone numbers also. We
Sure.
can be in touch. I'm sharing my phone number.
Yeah.
I shared my phone number. We can be in touch. Thank you.
Yeah, Hari. Thanks a lot for your contribution, Hari.
Thank you, Anurag. Thanks, Bhunesh.
Thanks a lot.
Yeah, bye.
Yeah.
Bhunesh, your mail ID and phone number.